Hello class, this is Lisa Henderson presenting the Data Technology Challenge for Week 3. My topic to explore clinical data mining was in regards to pressure ulcers. For those of us working within the hospital setting, the emphasis on preventing pressure ulcers should be a common challenge we share. At our organization, we use the Braden scale for identification and have a skincare bundle order set with nursing interventions to prevent pressure ulcer from developing. Yet despite these efforts, we inevitably still develop pressure ulcers in patients, demonstrating the need for further work to be done in this area. My article reviewed the use of clinical data mining to contribute to the knowledge base of how other factors combined with the Braden scale can be useful in determining the likelihood of patients developing pressure ulcers. The authors recognize that data mining techniques have already been used in healthcare, but are not currently used as much in nursing research. To overview, pressure ulcers are a significant burden for patients and on the overall healthcare system. They are associated with increased hospital mortality, and according to this research article, as of 2008, hospital-acquired stage 3 and 4 pressure ulcers were no longer reimbursed by the U.S. Centers for Medicare and Medicaid Services. Therefore, hospitals have to cover the cost of care for pressure ulcers, which average over $43,000 per patient. In addition, further risk stratification for identification and prevention of pressure ulcers can improve our patient outcomes. It is essential to investigate how other factors besides the Braden scale could enhance the prediction of pressure ulcers. As there are multiple potential causes, healthcare organizations must consistently monitor patients for pressure ulcer rates, assess risk, and enhance prevention efforts. Using clinical data mining, which is the digging for or mining of prior unknown useful information from data, we can increase with the increased use of electronic health records. There is a greater pool of clinical data to review, which could improve clinical care as hospitals study their current practices and learn from their own patients. Analyzing clinical data collected from electronic health records and comparing those who did and did not develop pressure ulcers can help us identify key measures for quality improvement. Data mining modeling techniques can be beneficial to conduct this analysis. The purpose of this article was to build and compare data mining models for understanding the varying causes associated with pressure ulcers. The authors carefully selected data mining techniques that provided high predictive accuracy while also allowing for meaningful interpretations. There are multiple factors which can impact a patient's potential to develop and recovery from a pressure ulcer, and it is important to see how these can enhance predicting pressure ulcers in concurrent use of the Braden scale. Because of the difficulty in capturing all aspects, data mining techniques provide a comprehensive assessment in determining the factors associated with pressure ulcers. The article reviewed 5 overall purposes for data mining. First, exploratory data analysis. Examining the data set with graphical pictures and basic descriptive statistics. Second, descriptive modeling, breaking down the data into groups. Third, a predictive modeling, building statistical models to predict variables. Fourth, discovering patterns and rules, finding items that occur frequently within databases. And then fifth, retrieval by content, identifying patterns in the data using the procedures from a prior analysis. Because the research objectives were to accurately predict pressure ulcer prevalence and identify clinically relevant factors, there were 4 predictive modeling methods selected. These data mining models were selected because of their high predictive performance and meaningful interpretations offered. Let's take a closer look. The first one is logistic regression. Logistic regression is the standard statistical generalized linear model approach for modeling 2 outcomes. The advantages of logistic regression includes simple linear structure, widely available fitting software, some flexibility to deal with categorical variables and model interaction terms. Some of the disadvantages of the logistic regression linear form stem from the same. Is that it may not provide a satisfactory fit with multiple variables and complex interactions because of the linear form. In this study, the logistic regression model indicated 5 factors associated with pressure ulcers: age, days in the hospital, serum albumin, BUN, and mobility. The second data mining model used was decision trees. Decision trees are a graphical representation of possible solutions to a decision based on certain conditions. It's called a decision tree because it starts with a single box, or a root, which then branches off into a number of solutions, just like a tree. Some of the advantages include efficiency in variable categories, its ability to assign specific values to problems, decisions, and outcomes of each decision, ease of understanding and handling missing data, and ability to deal with complex interactions. One of the drawbacks of the tree model is that they are highly data adaptive and unstable, meaning that minor alterations in the sample data may cause dramatic changes in the tree model structure. Also, predictions from a single tree analysis are often unsatisfactory. In this study, we see the decision tree model results demonstrating the impact of mobility, length of stay, and serum albumin, and then BUN further broken down. We see that patients with high serum albumin have a high predictive potential for pressure ulcers. The third data mining technique used was random forest. This method helps us address the weakness of a single decision tree by borrowing strength from the instability of tree models. Trees are unstable in the sense that predictions from each single tree tend to have a small bias but a large variance. As a model ensemble method, random forests reduce variance by averaging the predicted values from a number of tree models. The main idea is a model ensemble. Build up a large number of tree models, and then combine the predictive power from all tree models. The advantages of random forest is it can achieve high prediction accuracy and can handle a large number of predictors of different types of missing data. The drawback of random forest is that it does not supply a clear form like an equation for prediction, and the model interpretation is not so easy compared to a single tree model. In this study, the random forest model ranked days in hospital, serum albumin, age, Braden score, BUN, creatinine, respectively, as variables that are associated with pressure ulcers. Further plotting with serum albumin indicates that patients with lower levels may have higher pressure ulcer prevalence. The fourth model used is the multivariate adaptive regression splines, or MARS. This is a statistical process for estimating relationships among variables. It is a form of regression analysis and can be seen as an extension of linear models that automatically models nonlinearities and interactions between variables. The final multivariate adaptive regression splines model can be written as a model form. MARS is similar to logistic regression in retaining a model form. However, it adds more flexibility in handling categories of variables and nonlinear patterns and interactions with little requirement on data preparation and variable selection. Its drawback is that it does not provide as good a fit as random forest technique. In this study, the MARS model identified serum albumin, mobility, BUN, and days in the hospital as significant variables that are associated with pressure ulcers. The random forest model had the highest accuracy for identifying factors associated with pressure ulcers in this article. The tree models revealed mobility and serum albumin as the strongest predictors. but all models were in agreement that using the Braden score alone is not adequate enough to identify risk for development of pressure ulcers. All data mining models selected the following as important factors associated with pressure ulcers: days in the hospital, serum albumin, and the mobility subscale. Overall, the Braden score's predictive ability can be improved by including these considerations. The mobility subscale was found to be an important predictive factor in pressure ulcer prevalence and should be carefully considered and measured. The final predictive model included the following order of importance to predicting pressure ulcers: days in the hospital, serum albumin, age, BUN, and the total Braden score. The data mining methodology used in this research can be applied to other hospitals as they analyze their own clinical data to discover factors which are associated with pressure ulcer development within their individual settings. This article has opened up a new door to support our organization's strategic goal of zero harm. Our current hospital-acquired pressure injury rate is below benchmark. However, there is still room for improvement, especially with prevention and identification. Our wound care team works hard at monitoring turning position documentation, educating on prevention strategies, and encouraging the use of interprofessional plans of care on skin integrity. Clinical data mining can help us uncover further preventative markers to look for and identify a wider range of patients who might be at risk for developing a pressure injury. As our use and understanding of electronic health records continues to advance, clinical data mining will be a useful tool in evaluating our current intervention strategies and develop new ones as we continue to strive towards zero harm patient care. Thank you for watching.